Hello, this is exercise 22A. We're going to look at a new topic. The topic's called moments, and the moment we're going to think of as a turning force. A force that creates some kind of turning action might be a better way of describing it. So before I start, by the way, you'll notice lots of things going on here. We've got this force on this crane. And the thing about a crane is it wants to pull it down. It's trying its best to make this. This is a heavy old thing it's trying to lift. So, this whole crane, if we're not careful, will tumble. And so what do? They put a weight on the other side. And that effectively is trying to pull it down. But, of course, if it was to go round, we'd have problems, but this weight effectively does the opposite. It pulls it this way and it prevents that turning motion, so now it won't tumble because we've got this weight. Notice one interesting feature of this is the fact that this shorter distance here and this very large distance here, and so the distances are important, and we'll see that now. We describe a moment of a force in terms of something down here, the moment of a force about some point A. So imagine we've got A here, and we've got this beam here acting away. This is like a piece of wood or a piece of metal or something. And at the end of it, we apply some force. It could be a downward force in terms of that might be a weight on the end of it, or it could be, as this is, it's being pulled upwards. But this creates almost like an action which is a turning motion for the beam, and it would produce a force, an action going around that way. That's like a clockwise motion, I suppose. And the direction of it matters. It could be clockwise or anti-clockwise. But notice it says the moment of a force about A is the force that you apply times the distance you are away. The bigger the distance, the bigger the turning force, the bigger the moment. And this word moment is what I want you to concentrate on. It's all very well me trying to describe it in terms of turns and forces and stuff, but it's really called the moment, which is an odd word to say the least. The units are just a result of the fact that it's force, which is newtons, times distance, which is meters, so the units are newton meters, so they're not particularly impressive units. Let's have a look at some questions so you can see this in action. A uniform rod of 6 meters. Alright, now notice it only shows this 5 meters long, and therefore this end, I suppose, is 1 meter, just at this little end here. Has weight 5 newtons. Now, something you should be aware of, it says uniform. That basically means it's kind of, you can rely on it being solid all the way through. There's no weighty bits at one end compared to the other. So what that means is we can know at the halfway point we have the center of mass, and that's where the weight acts. So the weight will always act in the middle of a uniform bar. That's what this is. And notice, what's it say? It's got a weight of 5 newtons. Now, point P is one end of the rod, and point Q is 5 meters from P. Okay, find the moment of its weight about the point P. Now, all we do then is from P, you'll notice we can essentially measure that, and that, well, I said this was in the middle, so I think by definition this distance here is 3 meters. And if this is true, this will be, remember what the moment is, the moment about P will be the force times the distance. We've already said the force is 5 newtons, so it's 5 times the distance, which I reckon is 3 meters away, and that's 15 Newton meters. Now you should really say whether it's clockwise or anti-clockwise, and I reckon that will go this way round. So I reckon that's clockwise. This is an unusual idea, isn't it? That's the answer, by the way. That's all I needed to do, find the moment. Let's pick a different colour pen so I can do it from the other end as well. Because the other end it says, well, it doesn't quite at the end, it says from Q. So again, I reckon 3 meters. I reckon all this is 3 meters. Since that's 1 meter there, I reckon this is only 2 meters from there to there. So when it says find the weight about Q, the moment of its weight about Q, well, now the moment is still force times distance. But now that force is 5 times the distance, which is 2. So that is 10 Newton meters. And critically, this now would have the effect of turning the bar that way round, about Q. So I'm going to call that anti-clockwise. That's what the answers say. 10 and 15 and 10, yeah. Clockwise and anti-clockwise. So let's do a different question now. It says a uniform rectangular lamina. Now, I should point out, lamina is like laminate flooring. It's flat and hard, and it's the flatness, I suppose, which is important. It's almost you can ignore its thickness as well. The uniform rectangular lamina measuring 0.4 by 0.6. I suppose it's like just a big piece of wood, really. Has center C and weight 8 newtons. Now, something you should be aware of is the lamina will have that weight 8 newtons, but it will act halfway between here, so it will act there, and it will act halfway down as well. That's the important thing, I suppose. So whenever I'm doing this, I've got to think to myself, it's halfway. You know, that's where the center of mass is. That's where the weight will act. So a uniform rectangular lamina measuring 0. has center C and weight 8. The lamina is free to rotate in a vertical plane about P. Alright, so it's rotating about there. And of course the weight is acting straight down, I've said here. So this is where the weight is acting. And we've got this other force over here, the 12 Newton force over here. But it says initially, find the moment of the about P of the weight. Now, the fact it's up there doesn't really matter. You can see it acting straight down, and we said it's a force times the distance. Now when I say the force, it's the perpendicular force, and of course this is a perpendicular force. It's going straight down compared to this going straight across, so they kind of are at right angles. So what's the distance? The distance is 0.3 meters, half of the 0.6. And what's the weight? Does it tell me? Yeah, 8 newtons. So this moment, I'm just going to write moment here, at P equals distance times force. Force times distance. That sounds like 2.4 Newton meters. And what about the 12 Newton force? Well, I'll go back to a different colour pen. I'll go for blue this time. The 12, well, that, I know it looks as if it's acting there, but it's not really. We have to think of this in terms of the distance from P. And you can see that's going there, and that's where the right angle is. So although it looks like a 12 Newton force there, we think of it acting all the way through this. We think of it going there. And so now when I do this, you can see I've got this distance here, and then my force coming off. So I'm just going to write here, it's a force times the distance again. My force is obviously the 12 newtons. Now you've got to pick the distance, which is at right angles to it though. So you can see it's 0.4 away at right angles to the force. And that sounds to me like 4.8 Newton meters. See what the answers say. 2.4. Oh, I didn't say where they're clockwise or not. Yeah, my numbers are right. Let's see if I talk clockwise or anti-clockwise. Well, this one you can see quite easily. If that was to rotate, it would definitely go clockwise. And this one as well, that would have the effect of moving this corner in this direction. So it would, they're both clockwise. I agree with that. Clockwise and clockwise. Let's do the third example. A uniform rod of 8 meters. 8 meters, so, and weight 10 newtons. So notice, because it's 8 meters, this is 4 meters on this side. And this is 4 meters on this side, but I don't know where P is. Let's see about this. And weight 10 newtons is acted on by a 7 newton and 3 newton force, as shown in the diagram. Oh, I see, it actually does say 2 meters and 2 meters. And at this end, we've got 7 newtons force pulling upwards, and then at this end we've got a 3 newton force pulling upwards. Find the resultant moment about P. Now this is the crux of it. These are the kind of questions you get mainly in questions that you then have to solve. So the whole point of this, I suppose, is what we're going to do is we're going to have our P, and we're going to say, well, what are the clockwise moments and what are the anti-clockwise moments? Now just label them. Think about this one. This one, I think, this force here, at the right angles, I think it would make it go that way round. So I think that's a clockwise force. Clockwise moment, sorry. Now what about this one? This one also, I think that would make the whole system move that way round. So I think that's a clockwise moment. What about this one? This one, well, that's kind of sending it that way. So I think that's an anti-clockwise moment. So I'm going to do, first of all, the clockwise moments. So going clockwise, ooh, look at that, that's pretty. Clockwise, we've got a force times distance. So my moments is, well, I've got two clockwise. So I've got force times distance. The force is 7 newtons, times by the distance is 2 meters away. Can you see that 7 Newton force is 2 meters away? Plus, because we're both going in clockwise directions, this is 2 meters as well, but now it's a 10 Newton force. Doesn't matter it's underneath, it's the effect that it's doing. The effect is it's making it move in a clockwise direction. So force times distance. So that's 14 plus 20, I reckon 34 Newton meters. What about anti-clockwise? Well, we've only got one of those, and that's, well, it's from P. So you need to get the distance, and you need to get the force. Well, the force is easy. Force, it tells me, it says 3 newtons. And the distance is 2 and 4 is 6. Notice I'm doing the distance of the force at right angles to the distance to P. And that's 6 meters away. So that's 18. So the overall effect, I've got 34 going one way, 18 going the other way. The net effect is 16 Newton meters. These effectively cancel each other out. And 16 Newton meters. Now, clockwise is the biggest winner, so it's clockwise. What did I say? 16 Newton meters clockwise. And that's it. As an introduction to moments, you're going to be doing some questions which require you to work out the moments. Sometimes there will just be one force acting, it will just be force times distance. Sometimes there will be more than one, in which case they might cancel out, like we just saw. So sometimes they might do moments around different points. You have to cope with all of those. Best of luck. This is exercise 22A.